Alright, derivatives of sine and cosine, and also the other trig functions. Now, I broke these out into two separate groups because this is one spot where sort of the not as hard calculus classes vary from the hard ones. Like, for example, in AP calculus, you'll definitely have to memorize, I say memorize, definitely know by heart, and most teachers will not let you use a note card in that class. So you're probably going to have to memorize all 6 of these, each one of the different trig functions if you're in AP calculus. Or if you're in a calculus class that's sort of aimed towards engineers or science majors in college. But if you're in like an econ level calculus class, like calculus for econ or calculus for pre-meds or whatever, there's a good chance that you have a slightly easier thing where you're not going to have to memorize all 6 of these. You might just need sine and cosine. So the first half of this video will be about sine and cosine, since they're the most common no matter what class you're taking. And then the second half, we'll get into these a little bit, which are a little bit, they look worse, but they're more obscure and there's 3 times as many of them. But you're still in a situation where, plug and chug through it all. And I want to mention once again that in this chapter, and therefore in this video, we're not going to be using the chain rule or the product rule or the quotient rule. So I know the chain rule is one of the most confusing things for a lot of students. I'm going to cover all these trig functions again in the chain rule chapter. I just want to introduce these formulas, introduce roughly what's going on, taking the derivatives of them, and then the chain rule chapter, repeat it all, only with much harder problems. So everyone has to do the chain rule, so no matter what calculus class you're in, you're going to end up in the same video in the chain rule chapter. If that's where you are right now, having trouble, you might want to just stop watching this right now and skip ahead to the chain rule chapter. Alright, so it's going to turn out these are very similar to the power rule and other rules we've already seen, where if you have a number out front, you're just going to leave it there. And then the derivative of whatever is actually here. So the derivative of sine x is just cosine x. So the answer to this one, if we're taking the derivative of this, obviously, is going to be 3 cosine x. If you want to take the derivative of 3 cosine x, you get 3, and then derivative of cosine x is negative sine x. And sometimes students ask me, hey, why do you write that twice? Like what I just did is I put 3 and then I put the negative sine x in parentheses, and then I had to rewrite it again. Why didn't I just write it correctly right off the bat? Well, the reason I put parentheses around stuff is when there's a negative sign in front of it, the easiest mistake to make, and the one I see students make super often, is they'll write it like this. They'll do, okay, so here's the 3. Then they'll say to themselves, oh, well, the derivative of cosine x is negative sine x. And then they look at that and they're like, I'm done. But what this says is 3 and then subtract sine x. What you really want is 3 times negative sine x or negative 3 sine x. Now obviously you're not as likely to make the mistake I just told you on a problem as simple as this, but what if it had been one of these more complicated derivatives where you got term after term after term, or maybe it's in the middle of some crazy chain rule or quotient rule problem where it's just like tons of terms. If you write down the negative sine x without parentheses around it and then keep going, and then it's like 2 minutes later you're to the next line and trying to look for terms to combine and stuff, you might not remember that the 3 minus sine x you wrote was 3 times sine x. Your brain 2 minutes later might look at that and say, oh, that's 3 minus sine x, and then you'll combine this 3 with some other number you got, and bingo, you just got the problem wrong. So that's why whenever you take the derivative of something that has a negative sign in front of it, just put it in parentheses so you remember it's multiplied, not subtracted. Alright, here's a few where we'll need the chain rule, so this video won't help you. The fact that we have a 3x here totally screws us up. The derivative of this is going to end up being negative 3 sine x, sine of 3x. So the chain rule is going to basically cause another 3 to be conjured from thin air. I'm not going to go into that now. I just wanted to point out when you have to use the chain rule, and this is one of those times. You can't just take a 3 outside. You can't just say, I have students all the time who are like, oh, can't I just move this 3 to here and just rewrite this as 3 cosine x, and then take the derivative as if it was 3 cosine x. Now, this thing right here, whatever the cosine is being taken of, like cosine of 3x, whatever I just said after the word of is called the argument of the trig function. You cannot touch this. It's just, you can't do anything to it, can't cancel anything out of it, can't multiply it by anything else. It's just, this is a inseparable unit. So you can't just go around pulling the 3 out willy-nilly. Same thing here, sine of 3x. Once again, we have an argument besides just x, so we got to use the chain rule. All right, one term at a time. If you have a couple of trig functions added together, not multiplied, but added, just take the derivative of them one at a time. So derivative of sine x is cosine x. Derivative of cosine is negative sine x. And we're done. If there's a number out front, just leave it. So we'll get negative 3, and then the derivative of sine is cosine. And then if there's a 4 outside, leave it. Derivative of cosine is negative sine. And once again, I'm going to put that in parentheses. That's going to create another step because now I got to rewrite it as negative 4 sine x. But you know what? Better to write a line again than it is to get the problem wrong. So way better to waste that extra 2 seconds to do things neat than to just rush through it and get something wrong. All right, multiplication, another batch of problems we cannot do with the video we're looking at. We got to use the product rule because of sine x times cosine x. No way around it. Similar thing here, only this is worse because we have sine squared times cosine, so it's a product rule, and there'd be a power rule, which means we're going to do a chain rule. So this problem requires both the product formula, the product rule, and the chain rule. Bummer. That's going to be in the chain rule chapter. We'll get into nasty stuff like that. All right, so that's it for sine and cosine in this video. Let's take a look at the other 4. They're not so bad. Once you work with these a bit, you'll start seeing the similarities. For example, tangent and cotangent are sort of like, you know, they're brother-sister co-functions, if you will. And you'll notice they have some similarities. Each one of them is equal to a secant squared. Tangent goes to secant, cotangent goes to cosecant. But either way, you've got a square on it, and you just happen to put a negative sign in front of the cosecant squared. But the same thing happens over here. Secant and cosecant are co-functions, and they have very similar looking derivatives. Secant has itself in the derivative, and cosecant has itself in its own derivative. Then you throw a tangent or a cotangent. There's kind of a pattern here. And you'll notice that whenever you have a cosecant in your derivative, you're going to have a negative sign as well. The same thing happens over here. We have a cosecant, which leads to a negative sign in front. So that's just one of those little things where I just sort of get in the habit of, you know what, if I write down a cosecant in a derivative problem, there's probably a negative sign in there somewhere also. All right, so find the derivative. Once again, just leave a 2 out front. And then what's the derivative of secant? I believe it's secant theta tan theta. All right, that was pretty easy. Negative 3, what's the derivative of tangent? Secant squared. And by the way, there's almost every calculus book has a table of derivatives somewhere in it. There's usually a kind of smallish one in the derivatives chapter that you're on right now probably. And then very often the good books have it in the front cover or back cover. So if you just open up to like literally the hard cover, very often there's a nice formula sheet in there. If you don't see it there, there's going to be one somewhere on this website, maybe the top of this chapter, maybe next to this video. Haven't figured it out yet, but I'm going to have just a PDF of a formula sheet you can print out so you'll have them all in one place. Because believe me, that is a lifesaver. And also give you something you can memorize from and stuff. But you should definitely find wherever they are in your book, find that page, put a big old fat bookmark in that page because you're going to be using it constantly. And you'll almost memorize them by accident if you just keep looking them up all the time to do all your homework. As usual, do all your homework because that's the only way to get good at derivatives is to just do tons of practice. Because there's so many little curveballs and tricks they can throw at you. You just got to do it. Cotangent theta. All right, so once again, when I put the minus sign, I put a parentheses around it because there's a minus sign. So we got negative 1/2 cosecant theta, cotangent theta. Not too bad. It's annoying to memorize these things, but once you've done that, not too shabby. All right, so once again, if we have a number in front or multiple terms, no big deal. Derivative of secant is secant theta tan theta minus 2 times cosecant, which is derivative of cosecant is negative cosecant cotangent. But now I've got 2 minus signs, so it's like I have to rewrite everything, but hey, it's worth it to get full credit. So that negative times negative is positive 2 cosecant theta cotangent theta. Pretty fun stuff. All right, negative 2 derivative of tangent is secant squared y. Now you'll notice that if I switch from theta to y or x or whatever, all these formulas are exactly the same. If you're doing a prime, that just means derivative with respect to whatever letter you got. So no big deal. Just keep using the same letter again and again. Plus 3, derivative of cotangent is negative cosecant squared y. So that means I got to rewrite it again. Negative 2 secant squared minus 3 cosecant squared y. All right, if you're working these along with the video, way to go. Yeah, like I always advocate for you guys to pause the video, try and work the problem on your own. Because even if you watch me do it and it looks like it makes sense, that doesn't mean you'll remember how to do it an hour from now when you're doing your homework. So and the same thing happens in class all the time to students, right? It always makes more sense in class than it does when you're sitting down to do your homework. So that's what these videos are all about. Multiplication. All right, so here's some we cannot do, unfortunately, with this chapter. Just like when you have a sine times a cosine, you're not going to be able to work it without the chain rule or product rule or something. Same thing here. Two things multiply together, can't do it. Same thing here. We got a 2x as the argument of a secant. Can't take the derivative without the chain rule. And for this last one, once again, we got some stuff going on. Tangents and cotangents multiply together. It's crazy. Now, I want to get you in the habit of whenever you see trig functions multiply together, you do want to be thinking to yourself, hey, could I somehow reduce those or cancel those? Kind of like your trig proofs back in trigonometry. Because you may recall that a tangent is a sine over cosine, and a cotangent is cosine over sine. So actually, these would cancel out a lot of the time, because cosine cancels cosine, sine cancels sine. So you'd think that maybe all this would cancel out. The problem is that we got 4y's on one of them, and we got 3y's for the second batch, and that's the only reason they did not cancel. If you got a tangent of 4y, cotangent 3y, it's apples and oranges. 4y and 3y totally different, and there's no way to fix that. There's no way to like pull out a 3 and pull out a 4 and make them both tangents of y. They just can't do that. So unfortunately, there's no way to reduce these. Otherwise, it would have been a pretty boring problem. But do keep your eye out for that, because all that stuff you learned in trig identities, where you know trig proofs, where you simplify and cross cancel and all that kind of junk, that's all still fair game. And a lot of times that's what's going to save your bacon in a tricky calculus problem, is that if a problem be unworkable or really hard if you don't reduce it, but then if you notice that, hey, that would actually cancel that or whatever, you could turn a really complicated quotient rule problem into a power rule problem, for example, that's much easier to work. All right, so got to keep an eye out. The truth is that the stuff I just showed you in this video, you'll rarely see on a test. You're almost always going to have to either do the product rule or the chain rule if you're taking the derivative of a trigonometry function. But, got to start somewhere, right? And hopefully this helped you sort of memorize those rules and get a look at them, so that when you get to the chain rule and product rule, you won't be totally unfamiliar with the trig formula derivative formulas.